Welcome and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star one on your phone to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Ms. Catherine Hambleton. Thank you. You may begin.
Good afternoon. I'm Catherine Hambleton with NASA's Office of Communications. After waving off a launch attempt on Monday, August 29th for the Artemis 1 mission, teams have been analyzing the data and discussing options to determine the next steps. Artemis 1 is a flight test to launch NASA's new rocket, the Space Launch System, and to send an uncrewed Orion spacecraft around the moon and thoroughly test the spacecraft systems before missions with crew. Here to talk with us about yesterday's operations and the path forward are Mike Sarafin, Artemis 1 mission manager from NASA headquarters, John Honeycutt, manager of the Space Launch System program from Marshall Space Flight Center, Charlie Blackwell-Thompson, Artemis launch director from the Exploration Ground Systems program at NASA's Kennedy Space Center, and Mark Berger, launch weather officer with the U.S. Space Force's 45th Weather Squadron. We'll have a few opening remarks from each of our speakers, and then we'll take questions from reporters on the phone line. Reporters can enter star one on the phone to be entered into the queue at any time. First, we will hear from Mike Sarafin. Mike?
Okay. Well, good afternoon. Thank you for joining us and for continuing to follow our mission and our program. As you recall from yesterday, we had a couple of challenges that we encountered, and that ultimately ended up in a scrub of the first launch attempt for Artemis 1. The day began with some weather challenges that delayed the start of tanking. And then once we got into the cryogenic loading of the vehicle, we encountered a leak at the tail service mast umbilical on the hydrogen side at the 8-inch quick disconnect. The team managed to work its way through loading the core stage and the upper stage in spite of that leak. And we got a fully loaded vehicle and went into the engine bleed demonstration and attempted to do the thermal conditioning of the RS-25 engines, but we were unable to get the engines within the thermal conditions required to commit to launch. That was something that we knew about coming out of the agency flight readiness review, that we would demonstrate that the first time in the launch countdown, and we knew that that was a risk to being able to successfully attempt a launch that day. In combination with that, we also had a vent valve issue on the core stage, and it was at that point that the team decided to knock off the launch attempt for that day. Since that time, the team has rested, and along with thousands of others, our operations teams, our engineers, and you folks on the call that we're here to follow the mission, folks got a good night's sleep. We came back and reviewed the data from Monday's launch attempt and met today as a mission management team with our operations and engineering teams at 3 p.m. Eastern Time, and here's what we agreed on. We agreed on what was called Option 1, which was to operationally change the loading procedure and start our engine chill down earlier. We also agreed to do some work at the pad to address the leak that we saw at the hydrogen tail service mast umbilical. And we also agreed to move our launch date to Saturday, September the 3rd. We are going to reconvene the mission management team on Thursday, September the 1st, to review our flight rationale and our overall readiness. So that's where we got to today, and I'll turn it back to you, Catherine.
Thanks. Next, we will go to John Honeycutt from the SLS program.
Okay. Thank you, Catherine. Yeah, I know we were all looking forward to having a launch yesterday, and I can assure you there's nobody more ready than to go fly the rocket than I am. We did run into some issues that we couldn't get dispositioned in real time yesterday and get to T0 in the launch window. As you've heard, we were doing what we call a kickstart bleed test yesterday during the test that we had planned on doing during the previous wet dress. We were unable to do that in the previous wet dress because We ran into a hydrogen leak at the 4-inch bleed, quick disconnect, that the team has since repaired. And so we're in the mode now of processing the data that we got and updating our approach prior to the next launch attempt. And so I'm confident with where the team's headed. I've spent most of the day with the team. The team's been looking at data last night and looking at data today, and based on what we've done with the core stage and the 4 engines at the Stennis Space Center for the Green Run test, I've got a lot of confidence in the design of the rocket. For good reasons, we did implement some differences in what we did during the Green Run. As of today, and based on the data that we've got, we think we can do something like what we did at the Stennis Space Center and put ourselves in a better position for launch. If we'd have gotten this data in the wet dress rehearsal number 4, we would be doing exactly what we're doing now. And so, as you heard Mike mention, and we talked it at our FRR, this was something that we were unable to do in wet dress rehearsal number 4, and it was a validation test that we needed to do. And so we've got a path forward to get where we need to get to support the next launch attempt. So, Catherine, I'll turn it back to you.
We'll go to Charlie Blackwell-Thompson next, our launch director.
Thank you, Catherine. Good evening, everyone. Let's see, I'll start off and talk a little bit about our launch countdown launch attempt yesterday, and some of the events and that went into that, and then also some of the issues that we observed. So around midnight, midnight on Monday, our team was right on schedule to start the cryogenic loading operations. The improvements that we made from wet dress with regard to what our timelines look like and our loading procedures all worked very well, and we were right where we wanted to be. We got delayed a little bit because of weather, and we certainly have weather restrictions, and I'm sure that Mark will talk a little bit about that. But we were delayed for about an hour from our tanking operations. Once we got going around 1 or so in the morning, we began filling the core stage. Of course, we start out with LOX and then move over to hydrogen. During the course of the LOX load, the lessons learned from our wet dress attempts were great. We didn't have any issues. The improvements that we made in our loading timelines as well as our software, we really didn't talk about anything LOX related yesterday. We did get into hydrogen. Our chill down was all nominal. Our slow fill was all nominal. When we got into fast fill, we did notice that we had an indication of some hydrogen in the TSMU purge can, and the team was able to adjust the flow rates during that operation and manage our way through the loading ops. But we did see some indication of a leak in the purge can. We managed through that. We really had a fairly uneventful upper stage load, so that was good. We got through our upper stage loading, and then, of course, as part of our plan was once we got to replenish on the core stage, we were going to do what we call the kickstart bleed. And we put those operations into work, and we did see that we had one engine that was reading a little bit out of family from the others. I know we're going to talk a little bit more about that. And so we had initiated some troubleshooting to try to resolve that, to try to bring that temperature back in family with what we were seeing on the other engines. Ultimately, that was not successful, and when we started to look at that, along with the timelines for additional troubleshooting, we was outside the bounds of being able to attempt within the window, and we went ahead and called the scrub for the day. The team did continue to do some data evaluations after that, gather some data at cryogenic conditions, and then a little bit later in the morning, we got into our drain operations. So since our scrub ops, our team has finished up our safing. The vehicle was drained, and we spent some time today talking about our go-forward plan and put that together. And I know we're going to talk a little bit about that. I know John's going to talk a little about the engine piece. I'll talk about some of our near-term activities related to the LH2 TSMU and the leaks that we saw there. We do intend to go ahead and, at the pad, open up the purge can on the back of that plate and take a look. We want to do some inspections, we want to do some retorques, and we also want to make a change relative to the purge going into the plate. And we can do all that while we're out at the pad. We're already getting access set up to start working that.
All right. Next, we'll go to Mark Berger, our launch weather officer.
Good evening, team. So kind of recapping what happened yesterday, the first issue arrived just before tanking. One of the constraints that we have weather-wise is that the threat of lightning within 5 miles of the pad must remain at or below 20%. Given some thunderstorms developing offshore, I wasn't comfortable with that threshold being met and offered a 40% chance of lightning within the pad. And those conditions continued for roughly an hour, delaying the tanking. We did not ever actually register lightning within 5 nautical miles, but we did have it about 7 or 8 nautical miles from the pad at closest approach. And so from that point onward, for a good balance of the remaining of the tanking, weather was pretty quiet. However, shortly after sunrise, we did start seeing on radar new showers and storms developing to the southeast, and those were being moved northwestward, and unfortunately did enter our constraint violation for weather right about the time that our launch opportunity T0 commenced. We were no-go for various weather concerns for roughly 3/4 of that window. However, we did clear all weather violations in the last 1/4 of the window after the launch attempt had already been scrubbed. Looking forward to Saturday, weather will be a little bit different than what we experienced yesterday. We will have a fairly strong onshore flow, and so that does favor showers and possibly a few thunderstorms moving in from the coast during the morning and early afternoon hours, so we'll have to watch that as far as tanking. But otherwise, typically with that kind of regime, we tend to have the sea breeze pushed well inland, and that's the main focus for shower and thunderstorm development during the afternoon, including the window. So I'm optimistic that we'll have at least some clear air to work with during the afternoon attempt on Saturday. However, again, the probability of weather violation at any point in the countdown still looks to remain rather high, just again, given the moist air mass and that fairly moist fetch of showers coming in off of the ocean.
Thank you. We'll now go to questions from reporters on the phone. Once again, please press *1 to join the queue. You can press *2 if your question is answered or you want to be removed from the queue. Please do state your name and to whom your question is directed, as well as your affiliation. And we do have quite a few questions in the queue, so we please ask that you stick to one question so that we can get to as many questions as possible. So first up, we'll have Marcia Dunn from Associated Press.
Yes, hi. Can you hear me?
Yes, thank you.
Yes, for John, please. You mentioned that you repaired the 4-inch quick disconnect. That it sounds like there was a 4-inch quick disconnect that was preventing the chill down of engine 3. Is that the one you're referring to that was repaired, and what was wrong with it, and how did you fix it? Thanks.
Yeah, so I will say yes, that did occur during wet dress number 4, and that's what the reason I referred to that is we wanted to get this engine bleed kickstart test done during wet dress number 4. That is, we do need the 4-inch QD, which does tie into the vehicle hydrogen bleed system. In order to do the test. We did have that leak. We violated some requirements, and Charlie and her team worked through that, and then we worked through the repairs. Charlie, I don't think your folks did most of the work on the repair. You want to talk about that?
Well, on the 4-inch, we actually went in, if you recall, and we changed seals. We did the inspections. And I will say that yesterday we had that, you know, when we go into Kickstart, we utilize that interface, and that interface was tight yesterday.
Yeah.
So the work that we did after Wet Dress 4 to fix that was successful.
Yes.
Thank you. Our next question is from Bill Harwood of CBS News.
Yeah, thank you very much, guys. You know, you told us you're going to change some procedures, but you haven't told us what you're going to do. Can you please walk us through the chill down process? In other words, my understanding is this is a pressure-fed system on the hydrogen side. You don't have pumps like you did on the shuttle. I've heard that the line going to engine 3 is longer than the others. I'm wondering if that's true. And how do you know you're getting liquid at the engine and it hasn't turned to gas? I just want to know how that process works, because I don't understand how you're going to get the engine back in the box you need for launch. If you could give us some of those details, I'd really appreciate it.
Yeah, Bill, good question. I'll try to outline that, and Charlie will probably have to help me out a little bit. But the configuration we've got is a lot like shuttle in the main propulsion system, with a couple of exceptions. One, we've got 4 engines instead of 3. And then on the shuttle system, we had each leg of the hydrogen feed system in the shuttle going to those 3 engines on the shuttle had a recirculation system in it. So that enabled us to get that warm gas pumped back into the hydrogen tank, and then it ultimately boiled off. From a hydrogen loading perspective, it's pretty much the same as we did in shuttle. We go through a phase where Charlie and her team chill down the facility, and once we get into that, we start into the vehicle chill down, then get into slow fill, transition into fast fill, then transition into topping, and then ultimately get into replenish in a vented phase. And so the design change from shuttle to SLS and the NPS system that gets us to where we need the bleed system is we're carrying all. We want to take that heat out of the engines and overboard. So instead of being able to dump it back into the hydrogen tank and let the hot hydrogen boil off and go to the top of the tank and out through the vent, we're sending that heat that comes from the engines out through the ground vent system. So that's the big difference in the configuration and how we load. Now, what we did, what we wanted to do in this engine bleed kickstart was use some temperature data on the vehicle to validate that we got good temperatures, liquid hydrogen flowing through the bleed system on all the engines. Engine 3 obviously is further away. It's the furthest one away from the bleed connection to the ground. However, we designed all 4 bleed lines that tie into the system manifold to have the same resistance as each other. So we don't see any difference in that's driving anything specifically for engine 3. Now, what we saw in the test yesterday, we wanted to drive all the temperatures down to roughly minus 420 degrees Fahrenheit. And we didn't get there on any of them. We got close on engines 1, 2, and 4, but we didn't get there on as close on engine 3. We isolated 3 to itself by closing the pre-valves on 1, 2, and 4, where we had flow going just through engine 3, and we still didn't get a good temperature measurement. So ultimately, what we're seeing is some positive data in the pressure measurements that we're seeing, some goodness on 4 of the engines, and a temperature that just seems totally out of bed on engine 3. So we are questioning the fidelity of these sensors. These sensors are not flight instrumentation. They were designed only to be development flight instrumentation, and so we're a little bit concerned about one of those sensors. But one thing I can tell you is that we're really seeing some goodness in the data and what the physics is telling us, in that when we do establish that bleed flow in the vehicle and out through the umbilical into the vent line on the ground, we're seeing good cold liquid hydrogen. So, and then I'll tell you, the other thing that's different about what we did at Stennis and what we did here at KSC yesterday. At Stennis, we initiated the bleed test early on in fast field. The engines weren't as chilled down as they were yesterday, and we did get good results. However, we did have a little bit higher fidelity instrumentation on the ground during the test at Stennis. That is the only operational difference in what we did at Stennis versus what we did here yesterday. Now, the reason we waited to do the kickstart test yesterday is, and you've heard Charlie talk about how precious her commodities are in LOX and hydrogen, is the technical team felt like it was all in the direction of goodness to wait until we got into replenish. We would have a full hydrogen tank and have it nice and cool and densified, so that when we did run the bleed test, we would be even in better shape. The engine bleed system is different also. That since we did have to redesign the vent relief system as part of the engine bleed system after the green run, because we realized we didn't have the right tubing size to meet the maximum working pressure for the design. Changed it out to a bigger line. Bigger line intuitively is goodness. Also, there's a difference in Stennis and here at KSC. We had a smaller hydrogen vent line on the ground, and here at KSC we got a larger vent line, and it is insulated. So all those things are in the direction of goodness of having good cold fluid. I think where we are today is, I think we've got enough data to put the story together, but we've still got to go put the pieces together. Charlie, you want to add anything to that?
I can't think of a thing to add, John.
Thanks, John. Our next question is from Chris Davenport of the Washington Post.
Yeah, thanks, and thanks, John, for that explanation. That helps a lot. I guess I'm just wondering if it sounds like the main thing you're going to change is to start the bleed test earlier, like you did at Stennis. So I'm just curious how much earlier you will start to do that. And if I'm hearing you right, it sounds like you had liquid hydrogen going through that engine 3. It reached the engine. You just weren't getting the temperature somehow that you wanted, and maybe that was a bad sensor. Is that right?
What I'm telling you is the data on the ground side looked that way, but on the vehicle side, especially for engine 3, it did not reflect that. And Charlie, you need to probably answer the one on the timeline if you think you can. I think you get better off at that than I am.
Yeah, so I was actually just pulling out my bar chart to take a look at exactly how much further, as John mentioned, right, we go through various phases of loading. We go through the fast fill, then we go through chopping, and then we go through replenish. I'll get you a time here, just let me do some quick calculations, but we will be pulling that back earlier into the fast fill operation, somewhere, in and around the 15 to 20 minutes in. So, I mean, it will be coming back for some period of time, and like I said, so give me just a minute before we end this. I'll give you where I think how much earlier that is.
Thanks, Charlie. We'll go ahead and take our next question from Kenneth Chang of the New York Times.
Hi, thank you. This is for John and Charlie. It sounds like one strong possibility is that it's a bad sensor, which suggests you might get the exact same readings on Saturday. Do you have rationale for going forward with launch? Or how do you decide whether to go forward with launch if you believe that it's just a bad sensor and everything's actually good?
Yeah, so based on what I've heard from the technical team today, what we need to do is continue to pour over the data and polish up our plan on putting the flight rationale together. I think we've got enough data to do that, but we'll have to let the data guide us.
All right, thanks. We'll take our next question from Irene Klotz of Aviation Week.
Thanks, Catherine. So, John, just to clarify, you're saying that you think that if you had done the kickstart prior to the LH replenish yesterday, you might not have had this problem?
I guess no, Irene, what I'm saying is the only thing that I know to change to replicate the success we had at Stennis is moving the test earlier in the timeline and changing a couple of variables. One, the timeline. Two, the engines will be around ambient temperature. And we did see that work at Stennis.
Thanks. And I don't know if I missed this, but did we actually get a percentage of the weather for a launch attempt on Saturday?
Hi, this is Mark. So right now it looks like the probability of a weather violation during the count will be somewhere in the neighborhood of 60%. And while that is a fairly high number, the reality is with this kind of onshore flow, typically these showers are quite sporadic as they reach the coast. So while I would expect us in all likelihood to have at least some threat of a violation during that 2-hour window, we have 2 hours to work with, and these showers tend to have quite a bit of real estate between them. So I still think we have a pretty good opportunity weather-wise to launch on Saturday.
Thank you, Mark. Our next question is from Nell Greenfield-Boyce of NPR.
Hey, can you all hear me?
Yes.
Okay, sorry to belabor this. I just want to make sure I totally understand. So it sounds like you can't see or think of anything physically different about Engine 3 that would explain why it didn't chill down the way you expected and the way you all had seen at Stennis. And the sensors you have on the ground make you think there is liquid fuel coming through. And so you think it might just be a dodgy sensor. And so you're going to start doing this earlier in the countdown next time. And you may decide that if things look good, you might go ahead with the launch. But right now you don't know that yet and you're thinking about it. Is that accurate enough?
You got it pretty much, with one exception, is we will have a plan for a no rather than us sitting around and scratching our heads, was it good enough or not? And so that's what we got to finish. We got to continue pouring over the data. We got to put the flight rationale together, anticipating that we're not going to get any better results on that engine 3 bleed temp sensor.
And I guess I would probably add, this is Charlie, that, one of the things that we've talked about over the course of since yesterday is, it makes sense to us as a team to replicate what we saw work at Stennis. And so that's the reason that we would look to go pull this, this kickstart back, if you will, so into the fast fill timeframe. And I did go look that up while we were talking, and that does mean we would do it about 30 to 45 minutes earlier than we had done.
Thanks, Charlie. Our next question is from Kristen Fisher of CNN.
Thank you. Two questions. One is just kind of scheduling. Can y'all please confirm the exact launch time for Saturday, the length of the window, and if Saturday is scrubbed due to weather, when the next launch attempt would be? And then I have one more quick one, please.
Hi, Christian. Yeah, so the launch time for a Saturday attempt would be 2:17 Eastern Time is the window open, and it's a 2-hour window. And I'll turn it over to Charlie to talk the scrub turnaround.
Yep, so the scrub turnaround, as always, will be driven by the reason that we scrub, but assuming that it's a weather scrub and we're not looking at any kind of technical issues, it's just commodity turnaround, then we could be ready as soon as 48 hours later. That would put a Saturday, Monday in play.
Thank you. Our next question is from Micah Maidenberg of the Wall Street Journal.
Hi, can everybody hear me okay?
Yes, we can.
Okay, great. I don't know if this is for Mike or for John or for Charlie, but just given some of the unknowns and some of the work you're still doing, what are the risks of kind of moving forward? You talked about option one, but is it the most risky one versus just simply rolling it back and looking at everything in the controlled facility, the VAB? Thanks.
Yeah, so Micah, we did kind of talk about the spectrum of options, and we are at the pad right now, and the rollback scenario could have essentially put us in the exact same posture that we find ourselves in right now, which is we may just need to change the operation slightly and the cryo loading slightly, as well as address this tail service mast umbilical leak, and we can do that at the pad or in the VAB. So we elected to proceed to do that at the pad. The other option that we discussed at length was whether or not we should do a dedicated test associated with exercising this hydrogen bleed, and there were some pros and cons to that. The cons were that it would put additional cycles on hardware with limited benefit. There was some benefit from an engineering standpoint, but in terms of our ability to execute the operation and get to a successful launch attempt, there were limited merits to doing that. I don't know, John, if you have anything to add on that, but we did kind of talk through that spectrum of options. Okay.
Thanks. Our next question is from Ramin Skiba of Wired Magazine.
Hi, thank you. I have a dumb question. I guess this is for Charlie or Mike, but I just want to know exactly what is an engine bleed, and is that the issue that has led to a Saturday rather than a Friday launch attempt?
Yeah, so this is John. I should probably take that one. Yeah, and so what you want to do in a rocket engine system that uses hydrogen as a fuel and oxygen as an oxidizer is you need to establish a way to make sure you chill down the engines. And so, in kind of auto racing, drag racing type terms, you don't ever see those cars go out on a racetrack or a drag strip without a good period of warm up. And we're similar to that, but what we need is to get the engines nicely conditioned so they're cold. And the way we do that is we send the liquid hydrogen out of the hydrogen tank to each individual engine that has its own bleed system, which is used to take the heat out of the engine as we chill it down.
Okay, thank you. Our next question is from Michael Greshko of National Geographic.
Hi, thanks for doing this. Yesterday we heard that you all were aiming for a chill down for those engines to 500 degrees Rankine, or just above 40 degrees Fahrenheit. John, could you speak to how close the engines actually got to that as reported by the SLS sensors? Not just engine 3, but 1, 2, and 4 as well. Thanks.
Michael, this is Mike. I'll just say right up front, I misspoke on that one, and then I'll turn it over to John. I misquoted a number, and I shouldn't have done that.
Yeah, so where we wanted to go was approximately 40 degrees Rankine. I mentioned earlier we converted that to Fahrenheit for folks, and so it's minus 420 Fahrenheit. Engine 3 was probably about 30 or 40 degrees warmer than engines 1, 2, and 4, and I'm kind of just pulling it off the top of my head without looking at the data plot, but I'm kind of thinking that engines 1, 2, and 4 were probably around minus 410, something like that. Yeah, so 1, 2, and 4 are pretty close. The temp sensor on engine 3, its indication was a little bit warmer, 40 degrees warmer. So about minus 380.
Thank you. All right, our next question is from Tom Costello of NBC News.
Hi, guys. Good afternoon, and forgive me for re-asking one question. Somebody's cell phone, maybe mine, distorted at the very moment you were talking about what happens if you don't go Saturday. So could I ask you to indulge me? What happens if Saturday ends up not being a possibility? Thank you.
Hey, this is Charlie. I can take that one. With all scrubs, it depends on the reason you scrub. That really drives your turnaround, but provided that it was a weather issue, we are driven by replenishment of our commodities, hydrogen being the primary driver, and we could go as soon as Monday. So 48 hours in our turnaround.
Thanks, Charlie. Our next question is from Jeff Faust of Space News.
Good evening. Question for John Honeycutt. Is there any history of temperature sensors malfunctioning in a way that they're off by 30 or 40 degrees versus simply not operating at all? And when were the last time these sensors calibrated and checked? Thanks.
As far as calibration and checked, I'm pretty sure that we didn't do it anymore after it left the factory. So it's been quite a bit ago. As far as just history on sensors, over the course of my career, I have seen many sensors on launch vehicles be erratic and work and not work and go out of calibration. So it's not terribly unusual.
Thanks, John. Our next question is from David Curley of the Discovery Channel.
Thanks very much. What are the margins? If you were at 410 on 1, 2, and 4, is that good enough? And do I understand correctly, by starting this earlier, why would you know if the sensor is malfunctioning? Will your flight plan just say if we're seeing it come out on the ground side at a cold enough temperature that we feel confident that it is a sensor?
Yes, I've shared with you what I know so far, but also I'll remind you again that the team is in the middle of pouring through the data and building the flight rationale. So I don't have that just yet, but I do expect us to be able to get there.
All right, thank you. Our next question is from Jasmine Julmis of WPBS. It looks like we lost Jasmine, so we'll go to Eric Berger of Ars Technica.
Hi, thanks for doing this. A couple questions. First of all, for Mike, would you characterize this as a wet dress with a possible attempt at launch, or is this a full-fledged launch attempt? And I just would love to hear your confidence in sort of reaching, T-minus 0. And then for John, I'm sorry to belabor this, but, when you talk about flight rationale, does that effectively mean you're inferring the temperature of engine number 3 from other data such as pressure readings or ground-based sensors? I'm just trying to understand, what's going to give you the confidence you need in engine 3's temperature. Thanks.
Yeah, Eric, we are going to try to launch on the 3rd, and coming into this prior attempt, yesterday's attempt, we said that if we couldn't thermally condition the engines, we're not going to launch, and that's the same posture that we're going into Saturday on. I don't see it as any different.
Yeah, Eric, I understand your question, and I'm in the middle of, and the team's in the middle of a big data exercise and an analysis exercise. I think, we understand the physics about how hydrogen performs, and it's not, the way the sensor is behaving doesn't line up with the physics of the situation. And so we will be looking at all the other data that we have to use it to make an informed decision whether or not we've got all the engines chilled down or not.
Thanks, John. Next question is from Joey Roulette of Reuters.
Thanks. I guess this is for Mike or John. What, if anything, I guess, would warrant calibrating and checking those faulty sensors, and what would that entail, or how long would that take? And also, what is going to be done, I guess, to address the leak in the tail service mast? Thanks.
Yeah, so Charlie probably can speak a little bit to both of them, but I do think an R&R of the sensor would cause us, we'd have to do a rollback to that to get access into the engine section.
And R&R of the sensor would, while we can gain engine section access out at the pad with some temporary access, it's likely not ideal. So that would be, I would say, some impact that would take us outside of launch period 25. With respect to the tail service mast and that purge can, as I said, we are already putting the access up at the pad to get into that. We believe that once we get access, we have about a shift and a half, 2 shifts worth of work, and then of course we have to button everything back up. But part of that work is to go in, check the torques on that flange, do an inspection, see if there's anything there, do some leak checks on it, and then we're also making a purge modification in that area.
And that's remove and replace for the R&R, correct? Thanks. Our next question is from Alicia Stowers of Mashable.
Hi, thank you. A question for John Honeycutt. So if you're questioning the integrity of this sensor, is there a potential to replace the sensor? Was that discussed, rather than trying it again, possibly getting another off reading, and then, still not knowing if the temp is really off? Thank you.
Yeah, so as we mentioned, replacing the sensor at the launch pad would be tricky. And Charlie just told us that we could get access, but it's not ideal. And so the only other alternative there is a rollback. What I would like to do, and what I plan to do with the help of the team, is put us in a situation that gets us the data we need to know that we've got the engines chilled down appropriately and go fly using the data that we've got access to today.
Thanks. We've got time for a couple more questions. We'll go to Emily Speck from Fox Weather next.
Hey, thanks for taking my question. My question's for Charlie. So with the weather delays and technical issues, it sounds like there just was not enough time in the countdown on Monday. On Saturday with this new plan, how confident are you that there will be enough time to work through any issues that might pop up?
Well, it depends really on the issues that pop up. So that's really tough to say. You know, what held us up on our attempt on Monday was the fact that we got a late start due to weather. And so then we, you know, our tanking timeline pushed into the window, and then we had a technical problem that to resolve that technical problem required more time than what we had in the window remaining. So it really all depends on, you know, when we have a weather issue. If we got started tanking on time and the weather wasn't an issue at tanking, then certainly, you know, we would have the balance of the window, which is expected to be about 2 hours to go resolve that. But it's tough to speculate because it all depends upon, you know, when we get the weather issues and what that impacts.
Thanks, Charlie. Our next question is from Gina Sinceri of ABC News.
I'm not sure who this question is for, but these engines flew on space shuttles. Are you expecting different performance from them on SLS from the shuttle? I'm just kind of trying to figure that one out.
Expecting similar performance. We're running them at a little bit higher power level, but expecting similar performance.
Thanks, John. Our next question is from Chris Gapehart of NASA Spaceflight.
Hi, thanks so much. A couple of questions for Charlie. One, I haven't heard anyone talk about the vent valve, the intertank vent valve that malfunctioned yesterday and prevented you from pressurizing the hydrogen tank. What's the status of that, and how confident are you that it will work on Saturday, and if it does close, that it will stay closed after it leaves the pad to maintain that pressure during flight? And also to this engine issue, how do you essentially, if you get into Saturday and you see the same temperature issues on engine 3, how do you essentially mask that from the ground launch sequencer and the ALS and the main engine controller so that they don't freak out when they go to light the engines and trip and abort after the engines start? Thank you.
Okay, so I'm going to start out, and then I'll have John Honeycutt add in here anything that I may miss. So when we talk about the issue, what I like to refer to as upstairs, right, the leak that we saw, I want to be really clear, we didn't have an issue with the vent valve, right? We had an issue with the intertank vent QD seal, right? So we have on that umbilical, we have a hydrogen vent up there, and it was in that cavity. So not totally unlike maybe what we saw in the TSMU. So we detected that we had a leak. Keep in mind the configuration that we were in. We had that area had gotten really warm just based on the configuration of the tank at the time. So when we got into some of our troubleshooting and we decided that we were ready to change configuration, it was very warm, and then you hit it with a very dynamic event. And so we believe that was part of what we have historically seen on shuttle and on this vehicle, that one of the things that can happen is that you can see some performance differences in your QD as you warm them up and as you get them cold. In fact, that's one of the ways in which we troubleshoot when we have a leak, is we allow something to warm up and then we hit it with some colder cryo temperatures and see if we can get like a QD to reseat that way. That's part of our troubleshooting plan. So we had it sitting there, it was very warm, and then as we got into the follow-on operations, we hit it with a very dynamic event, hit it with some very cold temperatures, and that's when we actually detected the leak. So we're pretty confident that it has to do with the fact that that the QD warmed up over the 3.5 hours with the full tank, and then we opened it with very saturated tank at a higher pressure. And so what we also saw is after we got into some of our later operations and we started to see the pressures change, that leak went away. And so we believe that it was very reflective of where we were at the time, and we don't expect to see that on our next launch attempt. And let's see, the other question I think was on.
How you gonna measure my temperature?
Oh yeah, the temperature. So I wanna. And that's the one that John talked about. We also have a temperature on the ground side, right, that is what we would call downstream of those bleed interface temperatures that are on the vehicle. And we have other temperatures and pressures, across the engine. So there's a suite of data. And so what John's team is looking at, and what our team is looking at with his team, is what set of data do we have available to us, not just limited to the single piece of instrumentation, that can help us establish that we have good flow across those engines. And once the team has reviewed that and they brought that forward, then we would implement that as part of our plan. It could be the same plan that we had on Monday. It could be a different plan. But we would go through, we would review that, we would practice that. And really, it will all be data-driven. The team's looking at the data. They will come forward if there are any changes to this particular launch commit criteria. And then we, of course, would go look at how to implement that within the ground launch sequencer, and we would go practice that within Environment 3.
Thanks, Charlie. And that's actually all the time that we have for today. Thank you all for joining us. You can listen to a replay of this teleconference online shortly. It will be posted on the Media Resources tab at nasa.gov/Artemis-1. And you can watch a live stream of the rocket on the pad at the KS YouTube channel. And, of course, you can follow along and learn more about the mission at nasa.gov/specials/Artemis-1. Thank you all again, and have a good evening.